Hi, I'm Michael from High Performance Customs here in Australia, and I'm going to talk to you today about 3 different spring-loaded tapping guides. These are very useful tools. They don't replace the more expensive tools, but they provide that flexibility when you want to hand tap a thread for better feel. These are our 3 tools that we're going to look at. There's this one here, which you can see. They're all made using different designs. They're all spring loaded, and this is the 3rd product. So we have product 1, product 2, product 3. We're going to do a test of their tolerance around the Z-axis. We'll also be looking at the materials, how they're used, and do an all-up comparison, including price. Hi, I've set the first tool up on our mill. We can see here, and I've taken it up under a little bit of strain so that the spring is compressed. We're going to test it for its tolerance around the Z-axis. So first of all, I'm going to push it away, and you'll notice here, if you come in and have a look, we've set it up on the 0 dial, and each graduation is 0.01 of a mil. So as I push it away, we see that it's moved about 13, what have we got, 10, 11, 12, about 13 and a bit. So that's 0.13 of a millimetre. I'll now pull it back the other way, back to 0, and we see it's moved about 0.9, so 0.09 of a millimetre. We get a different variation on this tool because of the design, because of that cutout where it uses a grub screw. But anyway, that's a different story. Okay, I'll move it back to the 0. Right, move back away. All right, I'll now set up product number 2, and we'll go through the same process. Okay, I've got product number 2 now all set up. It's been put into the mill. It's been put under a little bit of load to compress the spring, and we've zeroed the dial. If you'd like to come in and we'll do the test. So similarly, we'll push it away and we'll see what sort of reading we get. And we've got about 0.18 of a mil in one direction. I'll bring it back to the 0. Whoops, gone too far. Back to 0. All right, and we'll take it in the opposite direction. So about 0.11 of a millimetre. All right, take it back to 0, take it back in the other way, test again. So 0.19 or nearly 0.2 and 0.1. So about 0.1 and 0.2 around the Z-axis. Okay, move out. Now we'll move on to product number 3. Okay, we've got product number 3 set up, same as before, loaded into the mill. We've brought the table up, compressing the spring, and we've set the gauge to 0. So same, we'll start by pushing it away, and we'll see how far she moves. So what have we got? About 0.03. Pushing in the opposite direction, take it back to 0. 0.02. So we can see that with this tool it has a tighter tolerance around the Z. Take it back to 0, do it again. Just a bit over 0.3. Take it back to 0 and 0.02. Hi, so we've finished now our tolerance test using the test dial around the Z market, and we noticed in summary that we had 0.12 and 0.3 on tool number 1, we had 0.2 and 0.19 on tool number 2, and we had 0.03 and 0.02 on tool number 3. So we can see that tool number 3 has the tightest tolerance. Now let's have a look at the design of these tools. This is tool number 1. And we notice that it uses a slot with a 30mm spring, and it's held in place with this cut in the surface there, which slots in there, and this grub screw holds it in place. Because of that cut, obviously you get a little bit more movement on that axis. It's a little bit tighter that way, but you still got a fair amount of movement there. Tool number 2, it has a different design. Similarly, it has a hole through. It has a pin with a collar, and this is the collar that gives it its degree of tolerance. But you can see we've got a little bit of movement through there. It tightens up when it goes through the opening. But again, we've got that little bit of movement. It's got a nice strong 50mm spring, which slots in the back there and goes in. I'll just put this one back together. And the last tool is this one here. Now the reason for the improved tolerance is this design, which are two conical surfaces that marry up exactly on the Z axis. So it holds it perfectly on the Z plane. So when it slides in, goes in there like that, it'll slide through, and you've got a reasonable tolerance in this neck as well. So you've got a tight tolerance there, a slip fit, then this fits in behind there. Again, that's a very tight fit. You push it down with the spring, it goes all the way in, and then that tightens up. So it's the design of this product that gives it that tight tolerance. In terms of the products themselves, I'll just put this one back together so we can talk about it. Slide that back in there. And just do up the grub screw. I did check this grub screw before I began the tolerance test, just to make sure that it was in firmly and that it wouldn't lead to any inaccurate measurements. Oops, there we go. So, in terms of finish and quality, the finish on this tool is quite good. It's probably will mark up over time. There's a few marks on it. This tool here, it seems like it's made out of a more mild steel, but it has a reasonable tolerance and a nice tight spring. You've only got about 10mm of movement on these. Although that one actually, no, it'll give you about 15mm of movement on that one, so you've got good movement in that nib. This one here is made out of 4140 steel, so it's very strong, particularly in the guide pin, and it'll give you about 15mm of movement. So a good degree of movement in there to start your thread, and you can probably cut the whole thread with that in place. In terms of price, okay, now move out. In terms of price, this one is only $15 plus GST or whatever postage is required. This one here is about $35 similarly. And this one here is about $50. We saw in terms of tolerance that this tool gave you the greatest degree of tolerance by a significant margin. This tool here was the next best, with this tool here being offering the least degree of tolerance around the Z axis. And it was actually different on different XY planes through it. So the choice is really yours. It depends on what level of accuracy you require for your job. If you don't require a high degree of accuracy, then either of these tools is going to serve your purposes. If you want a greater degree of accuracy for only a slightly increased price, then this tool is definitely going to surpass that. 0.02 to 0.03 tolerance. That's very fine. Anyway, the choice is yours. I'll leave it with you. Thank you. Bye.